Okay, grade 11 Precal. This is lesson 38. This is the last one of the unit. It's called graphing reciprocal functions. You really got to get used to doing this one, especially when you hit grade 12 Precal. We do a lot of this. So what we're going to do is reciprocal is just take it and flip it. So it's if we have y equals f of x, we just flip it. It's going to be y equals 1 over f of x. So let's start with by graphing y equals x, right? Just a linear equation, right? So if you look down here, we've just put a bunch of key x values, -10, threw some fractions in, negatives, and all the way up to positives. You'll see why I put some fractions in a sec. And if we graph those, it's easy. If x is -10, then y is -10. If x is -5, then y is -5. So we just graph that and we get a line right there. Now, let's talk about the reciprocal of it. So the reciprocal of -10 is -1 over 10. The reciprocal of -5 is -1/5, and so forth. -2 is -1/2. Oh, look at this one. -1, the reciprocal of -1 is -1. That's interesting. Those points are the same on the original as they are in the reciprocal. That's good to note. That's important. -1/2 will be -2, right, and so forth. Now look at here, 0. What is 1 over 0? Well, that's undefined, so that point does not exist. Okay, so we have a problem there. There's an undefined one. Let me just keep working back here. -5. Oh, look at this one again. 1, 1, and 1. Hey, the reciprocal of 1 is 1. There's another key thing. So what we have is we have an asymptote in there, and this thing is called a line whose distance from a given curve approaches 0. So if you look, do we have an undefined value in here? Yes, we do. So right here, the y-axis, as in x equals 0, is going to be our vertical asymptote. Oh, okay. So then we start plotting the points. You can see they actually form a really kind of a neat curve on here. Now, the key ones, sorry, this graph is a little bit off. The key ones are right there. 1, 1, and -1, -1. Those, look up here. They're the same there, right there. They're the same there, and the same there. Those are known as invariant points, and we're going to use those in the future to help us graph stuff. Okay, so vertical asymptote. For reciprocal functions, it occurs at the non-permissible value. So our vertical asymptote, there's the non-permissible when x is 0, right? Horizontal is basically, in grade 11, is always going to be the y-axis. And if you look here, there's our asymptote here. In grade 12, this asymptote is going to move around. It's going to move up, it's going to move down, and then it's going to be oblique, which is like a line. Okay? So that's the basic reciprocal. So if you struggle with that, just graph your y equals x and then start flipping all your values here. The key ones are 1, 1 and -1, -1. Okay, flip the page and let's look at an example. This hopefully makes more sense as we go along. We're going to do linear and we're also going to do quadratics. Okay, now here's a linear one. Y equals, or f of x equals 2x plus 5. So if you're trying to create the reciprocal of it, probably the easiest way is to, if you look here, graph the original. It's just linear, right? So y equals 2x plus 5, you start at +5, and then you move up 2 over 1. Now, sorry, the graph is off a bit. It sometimes changes when you're on the computer screen here. So the reciprocal is 1 over 2x plus 5, okay? The vertical asymptote, all we do is we set the denominator, right, non-permissible value, set it equal to 0, right there. Set it equal to 0, do the math. So we have an NPV at -5 over 2, which is -2.5. You can see there's our vertical asymptote at x equals -5 over 2. Where's our horizontal? Well, that's easy. In grade 11, it's going to be right here on the x-axis. Okay, and then we can go ahead and just do some key things here. Okay, now, here comes the invariant. Well, we can talk about the invariant points. Y equals 1 and y equals -1 are invariant points. You set them equal to that, and then you can actually solve for any of this. So if you set y equal to 1, plug it into the equation, find out what the x value is, plug in -1, plug it in, and you'll find out what the x value is. Those are get you your invariant points. And this general shape is for linear. Sometimes they'll be in like this quadrant and this quadrant, and then sometimes they'll be in this quadrant and this quadrant. Those are the two general shapes you'll see. There'll be a few variations on that. It's the same with quadratics coming up. There's a general shape that they always form. The easiest way is if you really get stuck doing this, make yourself a little table of values, and that'll help you get the general shape of this. Find y-intercepts. That always works. Even in this case, the y-intercept is when x equals 0. We'll plug in x equals 0 back up here. 2 times 0, 0, plus 5 is 5. So 1/5. Oh, you can see right away, yeah, that point right there, the y-intercept is 0, 1/5. All right, flip to the third page, and we'll do a quadratic. So there's our quadratic. F of x equals x squared minus 4, or y equals x squared minus 4 if you don't like that. The reciprocal of that is just 1 over that. So if you're struggling with this, graph the original. You can see the dark line here is the original. It's a regular quadratic, and the whole thing has been shifted down 4. So our y-intercept is -4, and the standard one is like over 1 up 1, over 2 up 4, right? Over 3 up 9. You can figure that out. Now, we want to do the reciprocal. So let's figure out the NPVs. Let's figure out, in this case, there's 2 asymptotes, vertical asymptotes. So here it is here, x squared minus 4. Set it equal to 0. Well, that's easy. That's a difference of squares. So we find out x equals -2 and +2. So our NPVs are 2 and -2. So we put our vertical dotted lines in. Asymptotes are always dotted lines. We put them in there. And actually, you should probably put in a dotted line here too for the horizontal. And again, if you see the horizontal, it's at the x-axis. Now, general shape. It's either going to be up here and down here, or the whole thing's reversed. It'll be up here, and both of them will be down here. Well, one of the easiest ways is to do that, to kind of get the general shape. Find the y-intercept. It's easy to find. Set x equal to 0. So we set x equal to 0. We end up with 1 over -4. Oh, so the old, right, on the original, the y-intercept was -4. This one is -1/4 because it's 1 over -4. So you can see it's right there. Oh, so this has to be the general shape. Now, let's talk about the invariant points. And the invariant points are the plots that are the points that are on the same on the original as they are on the reciprocal. And it's easy. All you do is set f of x or y equal to plus or minus 1. So you set y equal to 1, do the work. Set y equal to -1 and do the work. Okay, so when we plug those in, we can actually just do the math. X squared minus 4 equals 1. X squared minus 4 equals -1. Plug it in, we find the y values. Now, they're going to work out as rationals. Don't change them to decimals. I mean, you can change them to decimals to get a general idea of where they are on the page, but always keep them as rationals. That's more accurate. So we end up with -5, 1 and root of 5, 1 and -root of 5, 1. That's one set of points. Root of 3, -1 and -root of 3, -1. And you can see right on there, oh yeah, that point there, it's on both the reciprocal and the original. That point right there, it's on both the original and the reciprocal, and same with these blue ones over here. So those are invariant points. And you can do that on any of these reciprocals. Set y equal to plus or minus 1, and you'll get the other values so you can plot them. Okay, last page. This one's kind of interesting. This is a going backwards question where you get a graph or you get an asymptote, you get some stuff, and you got to work back to figure out what the original equation was. So what you have here is the graph of the reciprocal. We know this is just 1 over whatever the original was. So let's look at some points here. So we have 3, 1/3. So hey, reciprocal of 1/3, 3, 3. Ah, okay. So that gives us a point on the original one. So 3, 1/3 right there was the part of this one. So there's the one there. Now, since the asymptote is y equals 2, the original graph has to have an x-intercept of 2, 0. Remember, because when you do the reciprocal of that, that creates your NPV. So it has to have one at 2, 0. So, well, hey, do you remember how to find slope? Slope formula, grade 9. Take your 2 points, 3, 3, 2, 0. Label them as x1, y1, x2, y2, right? Plug them in, you get a slope of 3. Okay? We know the slope is 3. We know that the point, it goes through 3, 3. So we can plug in 3, 3 on the slope, figure out what b is, work backwards, figure out what the y-intercept is. So we do the math, we find out b is -6. So based on that, if we know the slope is 3 and the y-intercept is -6, we can figure out our equation right here, y equals 3x minus 6. And if you look, y equals, oh yeah, there's the -6, up 3 over 1, up 3 over 1. Oh, that's the x-intercept, which is going to be our asymptote or NPV, up 3 over 1. There's our point 3, 3, right? So that works. So it's a little bit trickier to work backwards, but you have the necessary tools to be able to figure that out. Okay, so that's the last lesson there.